Okay, so now let me move on to the last presentation in this session. Is there a speaker of the third paper, Player TV? All right. Are you online?
Yeah.
Okay, so the third presentation of this session is by Dr. Hekon, Merrick Solberg, Mehdi Hausman, and well, it's a little bit difficult for me. So and others. So the title of the presentation is Player TV: Advanced Player Tracking and Identification for Automatic Soccer Highlight Clips. So when you're ready, please get started.
Good morning, everyone. Can you hear me and see my screen? Everything is fine?
Yes.
Yeah, perfect. Yeah, it's almost around 2 a.m. here, morning in Oslo. So very early morning for me. Yeah. So to introduce myself, my name is Sushant Gautam, and I am a second year PhD student at Simla Metropolitan Center for Digital Engineering in Norway, and I work around soccer or football game understanding. Today, I'm excited to present our paper Player TV, Advanced Player Tracking and Identification for Automatic Soccer Highlight Clips. It's a framework. It's designed to revolutionize sport analytics by automating the generation of player-specific highlight videos. So let's move on. So manual highlight generation it's a very tedious job. It limits scalability in sports analytics. Imagine combining and like looking hours of footage to create tactical insights or performance reviews. So Player TV addresses this gap by automating these processes. We are trying to replace the traditional manual approach where you have to like see through lots of videos and you have to tag lots of videos, crop all those videos, and we are trying to replace this method with our automated solution, emphasizing the potential for tactical analysis, performance assessment, and fan engagement. So here is a visual overview of the framework Player TV, showcasing its modular architecture and seamless functionality. So yeah, there are a lot of components in this chart. So it outlines the 5 core modules of our pipeline, which I'll be explaining in detail as we progress. But you can see these modules, which are numbered here, like 1, 2, 3, 4, 5. So it's an integration of cutting edge technologies like object detection, player tracking, OCR, and color analysis. So our framework is modular, allowing it to identify players accurately and generate highlight effortlessly. So it automates what has traditionally been a labor-intensive process. So we get some video and some input from users, and we track the players that user want to generate highlight, and we do some color mappings and team mappings, and we also do OCR to figure out the jersey number of that player, and we map the player to the right team, and we crop the video of that player only in the big video sequence. So this is what we do with this pipeline, and at the end you get a highlight clip highlighting that particular player that you chose in the input. So yeah, this is the overall thing, and I will try to explain it in more detail. So sport analytics have evolved significantly, utilizing mostly AI to enhance team performance, strategic planning, and even enhancing fan experience. From event detections to game summarizations and multimodal analysis, the field has been ripe with innovation. So Player TV fits perfectly within this ecosystem, leveraging state-of-art tools to push the boundaries of sport analytics. So we have used a tracker named Deep EIOU, and this is the heart of Player TV's tracking module. It excels in managing challenges like occlusions and fast-paced movements, which are common in soccer, as you can see in the figure. So there are players moving here and there, and the camera movements, and so on. So this figure, this video illustrates how a robust tracker like Deep EIOU and a good object detector like YOLO performs robustly under dynamic conditions. So another module is color mapping module, and it needs to distinguish teams by analyzing color clusters using advanced spaces like Scilab. This pre-processing steps ensures accurate team mapping even under challenging conditions. For example, like the problem with lightning is it's shown in the figure here on the left. So on the right, here is an example of clustering result where we map all jersey colors of the players detected into RGB space, and there are distinctly visible color clusters. So we can figure out that there are two different teams. One is red and one have black jersey, and like there are two teams with two different jersey. And and this approach, this clustering approach, highlights the effectiveness of our approach. So accurately identifying a player requires extracting kit numbers, and this is where OCR plays a crucial role. While challenging conditions like occlusions, as you can see here in the pictures, and low light persist, our scoring mechanism and pre-processing steps significantly improves recognition accuracy. And these outputs demonstrate the model's potential in real-world scenarios. So I will show some evaluation later on. So PLayerTV's user-friendly GUI, as you can see here, enables seamless interaction with the framework. Users can configure pipeline parameters, select players, and generate highlights with a few clicks. So yeah, you have to select some metadata that includes the information about the video and like teams and stuff. So you just select what you want, and you just select the algorithms that you want to try, and click on this clip video. Then this system will generate a highlight video that will only contain the highlight of the players that was in the selection. So for example, like this bounding box is shown to just highlight this player was selected. So I will also try to show an interactive demo if it works here. Let's see. So yeah, this is the PLayerTV demo. It's public, but I would have shared this with you, but we need some configuration file which is not public. So yeah, I would try it with this one. So yeah, it will load some video here. Yeah, as you can see, it's like 36-second video. Yeah, it could be a bit longer as well, but yeah, it takes some time to pre-process. So we have options to choose teams. If there is jersey in database, it will be shown here. For example, for Lidstrom, it is shown. Okay, let's choose this one, Paleranga. And we can choose the player that you want to generate highlight for. I mean, it automatically calculated all the players that were here. So let's try to come up with some. Okay, let's try this one, this player. And there are different methods here. We can choose which method we want to use. Okay, let's choose the default one here, and we click video. And this system will now use this method to extract the part of the video where this particular player was shown here. So it will take some time. So okay, it's just in our 24, Peter. Yeah. So yeah, okay, it's just 2 seconds, but yeah, this is all the places where he was shown. This is the guy. Yeah. So this is the way that it works. Okay, let me get back to my presentation. So this is the evaluation output of PLayerTV. To evaluate PLayerTV, we tested it on datasets from Norwegian Eliteserien League under diverse conditions. So this table presents our result, including metrics like team mapping accuracy and OCR performance. We also encountered challenging lighting scenarios, as I mentioned before, and it's shown in the figure. For example, this highlighted row here. In this video, the lighting condition was very worse. It was very difficult for even human to identify the jersey number. So the model, the OCR model failed here. So the scores is very low here. It's 0, right? So here are output from different modules. So this is team mapping module. You can see like this column, and this is from OCR. So we have used modular components. So like there are two different alternatives here, and there are two different scores for each of the alternative as well. So we run this model offline or online. So online would be lower score. So if the model is run offline, it can see the future frames as well. So it will have higher score. So this is what the scores are. So it is mentioned in detail in the paper. So OCR performance is shown here in this column. It is a bottleneck here. So, but pedal OCR, this algorithm shows promise, outperforming another algorithm, easy OCR, by a factor of 3 in many cases here. So enhancing this OCR accuracy will directly improve overall pipeline performance, and this result demonstrates the module's current capability and area for future development. And our experiment shows that the Scilab color space, it outperforms weighted RGB in distinguishing team colors using the clustering approach I showed before. So this Scilab color space achieves an accuracy improvement of nearly 4% overall. And this table illustrates the performance difference, highlighting the significance of accurate team mapping for this pipeline success. So the performance matching metrics combined with our modular design makes this framework suitable for targeted applications, paving the way for live game analysis and broadcasting enhancement. So the problem with this pipeline is that it processes frame at a very slow rate, approximately 1 frame per second. So we are using GPU, it's Tesla V100, and we are using OCR algorithm, which is a bit slow, and also the tracking algorithm DPIOU. It's an iterative method, so it's also a bottleneck here. So the algorithm is quite slow at the moment, as you saw in the video, in the demo I showed earlier. So this is the problem we have now. So yeah. So the potential application of PLayerTV are vast. It could be from tactical analysis and performance reviews to immersive fan experiences and injury prevention. So our framework has potential to transform multiple facets of sport analytics. So here are some use cases. It could also include AR overlays and tactical heat maps to illustrate its variability. Here are the list. So it's more is detailed in the paper. So PLayerTV is open source. We invite contributions from researchers and developers. So you can find the repo from this GitHub link. You can scan the QR, and it's also mentioned in the paper. So this GitHub repository contains the complete code base and documentations. And by making our framework accessible, we aim to foster innovation and collaboration in the sports analytics community. So in conclusion, PLayerTV represents a significant leap in automating sports analytics. While our results are promising, there is definitely room for improvement, particularly in OCR accuracy and making this framework real time. So future developments will focus on this area as well as expanding this framework beyond soccer. So before we wrap up, I would like to express my heartfelt thanks to the organizer for accommodating my remote participation. While I regret not being able to join you all in person in this beautiful country, Japan, I truly appreciate the opportunity to present this work to such an esteemed audience. Thank you for your attention, and now I would be happy to take any questions or suggestions you might have.
Thank you very much for your presentation. So now it's time for discussion. Any questions or comments from online or on-site? Okay, so I have one question. So what about the minimum resolution to recognize the kit number of a player?
Okay, let me go back to the pipeline. Yeah, okay. Because all the video it go to tracking, so it depends on like how accurate you want to track. So we are using yellow X for detection. So yeah, detection is required for tracking. So it is the requirement of the detection algorithm now. So usually what we do is like we use 500 height. So the width should be something around like 800 or something like that. So yeah, it's around 512 pixel in by height. So yeah, it is the input to the detector, but it depends on the complexity of the detector that we want to use, and like if it is higher, it will take a long time, right? So yeah, this is the thing that we are using now. So yeah, not so higher quality because we have access to very high quality videos, but yeah, it will slow down the detector and tracking algorithms and so on. So yeah, this is the bottleneck, and like yeah, we are using around like 512 pixel by height now.
So what kind of improvement is considerable for the improvement of the kit number recognition? Because
yeah,
current accuracy for kit number recognition is not so much so much satisfactory for maybe users.
Yeah, exactly. Yeah. So identifying kit numbers from these wild videos from the stadium is very difficult. For example, you can see in this picture, like in lots of frames, like the kit number isn't visible for users, so it's very difficult for us humans to guess as well. So yeah, I admit that OCR algorithms have evolved a lot in recent years, and they are very accurate now. But like these conditions, for example, like when players are moving so fast, it's almost impossible to identify. So yeah, it's also like the complexity of the problem. And yeah, let's hope that in the future there will be some this tracking aware OCR algorithms that will be able to resolve this kind of cases and will be able to track this kind of kit numbers from the video. So yeah, when we have this kind of algorithms, then it will be easy for us, and it will be yeah, it will improve the scores around this and the scores of overall.
Okay, so any other
pipeline is the bottleneck as of now.
Okay, so any other questions? Oh, okay. Oh,
But in order to track the player, I don't think you need the OCR to work for every frame, right? So like it can work for like 10, 20 frames, and then you can still. So I think, perhaps you should also explore the possibility of using other information for tracking just than the OCR itself.
Yeah. So yeah, as you can see in the picture, like we don't need to. The OCR is done after player tracking. So we first track player. So it's using DPIOE algorithm. I think it's still the state of art algorithm for player tracking. So like we track the players, then we have the stream tracklet of the player. Then on that tracklet we perform OCR. It's very efficient way of doing this. So I mean, instead of just OCRing all the video frames, we first track the player and we know like where the player is. I mean, throughout all the frames. So we just crop that. As you can see here, this is the picture of tracklet. So we first track, then we crop the players, then we do OCR. So that it's very efficient to do on this because like there are no other environmental stuff here, like no other background noises and stuff. So it's very accurate. So like we found this way very efficient. Yeah. So yeah, I think it aligns with what you suggested, right?
Okay, so I also think that it's just an idea, but is it possible to apply, for example, gate recognition in order not to rely on kit number recognition, but for the keep track of the individual player?
Pardon me, I missed what recognition did you mention?
So there is the idea of gate recognition. So the pattern of running or walking can be the proof for human identification. So applicable for that idea even for player re-identification for this application.
Yeah, I have seen some papers like that did this approach in the past, but I mean, I'm also trying to use this technology now in some other application. And the problem with this is like, I mean, we usually do post tracking there, and like we get this body coordinates, and we apply some algorithm on top of that. I mean, that's the approach that I have been exploring now for other applications. And the problem is that it's very noisy because in the video the size of player is very small compared to the whole screen. So like when they are moving here and there, like it's very noisy signal, and like it doesn't give so much like signal for like this gate algorithms to properly distinguish between players. So yeah, I mean it should be. I need to check like latest literatures to see like what progress has been there. But I mean, yeah, OCR should be like far better than also explainable way to like figure out, because you can visually figure out like if it is working correctly or not as well. So like that's why we chose to go with OCR, because yeah, it has been very mature over the years, this technology. So yeah, it would be definitely a good alternative to explore. But yeah, I personally believe that it should be like better way rather than doing this gate analysis and like trying to like have some notion of like figuring out which of the players should be having this. Like it's a like guessing approach, but this is more visual and like more easier way to evaluate it better. So yeah, it's my personal opinion, but yeah, I would have to check with the details.
Okay, so it's well, time is exceeded. So thank you very much for your presentation again.
Yeah, thank you for the nice questions. Yeah, I really love it.
This is all for this session. Thank you very much for all of the speaker and active discussion from the audience.